Okay guys, this is your Unit 15 introduction. We are going to start by watching video 1 a little bit. Kind of gives you a little help here. I might fast forward through some of it.
How do you subtract 3 1/8 minus 1 1/8? In this lesson, you will learn how to subtract mixed numbers with like denominators by using equivalent fractions. Let's review. When we have a fraction, or in this case an area model, that is choosing all the parts, or they are all shaded, then we have one whole area model filled in. Our fraction will look like, in the case of these two area models, well, in this area model, 3 over 3, which is one whole. That means all parts are chosen out of the number of parts that are in the area model. Our second area model shows 8 parts shaded. To name the denominator, we see how the area model is equally divided. In this area model, we see that each area model has 4 parts. So our fraction is 8 over 4, which is equal to 2 wholes. Let's review. An improper fraction is a fraction that has a numerator that is larger than the denominator. One of the ways that we know how to show a mixed number is to use a picture to show the improper fraction. The way we figure out how to represent our improper fraction is to look at the denominator to tell us how many parts are in the whole. We need to count each individual part to determine how to represent the fraction. So if we were to name this mixed number, it would be 3 wholes and 3 out of 4 parts.
You should have also practiced this a little bit before we got out of school. You would divide this to get 3 3/4. This is just explaining the visual.
Here's a common mistake. So a common mistake is that the whole number, 3, is placed next to or in front of the numerator 3 to make 33. This improper fraction is different from 3 wholes and 3/8 of a whole. When we create an area model, we have an area model that is equally divided into 8 parts to make a whole. The fraction tells us that we have 3 wholes, so we need to show 3 area models equally divided into 8 parts, shaded to show 3 wholes. The fraction is 3/8, so in order to represent this fraction, we need to show an area model equally divided into 8 parts and shade 3 parts to show 3/8. If we were to look at 33/8, this area model is different from 3 3/8. Here's our first problem. 3 3/8 minus 1 1/8. So in order to subtract these mixed numbers, we are going to replace each mixed number with an equivalent fraction.
So in order to subtract these, you're going to need to turn both of them into improper fractions. I have taught my class to round their wagons. This video is going to do it a little bit differently, but you're still going to get the same outcome. So in order to round your wagons for this, you would do 3 times 8, which is 24, plus 3 would be 27/8. Okay, minus, round your wagons here. 1 times 8 is 8, plus 1 is 9, 9/8. The number one thing when you subtract or add fractions, they need to have the denominators the same. So that would give us the same denominator. I'm going to continue with this video. It does do it a little differently. It doesn't say round your wagons, but you still convert it to an improper fraction.
In subtraction, order matters. Our denominator tells us how many parts make up a whole. In this case, we have 8. Our whole number is 3, so we need to have 3 wholes. So I'm going to count by 8. 8, 16, 24 to represent 3 wholes. I need to add 3 more parts to represent 3 3/8 as an equivalent fraction, which gives me an answer of 27/8. Our second fraction, or our second mixed number, is 1 1/8. My denominator is 8, and I only need 1. So with counting by 8, I will still have 8. Plus 1 more will give me 9 over 8. My denominators are the same, so I do not need to change them at all. Now I need to subtract. 27 minus 9 equals 18 over 8.
Okay, now that you have converted both of those mixed numbers into improper fractions and they both have the same denominator, you can actually just move 8 over. The denominator is going to stay the same, and you are going to subtract just the numerators now. So 27 minus 9 is 18. However, you cannot leave 18 eighths like that. You must convert it back into a mixed number.
Here's our second example. 3 2/4 minus 2 1/4. Let's subtract 3 2/4 minus 2 1/4. In order to subtract these mixed numbers, we're going to replace each mixed number with an equivalent fraction. In subtraction, order matters. Our denominator tells us how many...
All right, I'm going to stop right there. I would advise you to finish watching that video. That's actually video 1, so you were supposed to watch it first. This is video 2. I'm not going to go through the whole thing, but I want you to see this is the subtraction. Adding is going to be very similar when you add mixed numbers. The first thing I want you to do is to convert both of them to improper fractions and then add them. And so this would be 2 times 8 is 16 plus 3, 19 eighths, plus 2 times 8 is 16, plus 4 is 28. So I want you to add those together, and then you will get another improper fraction, and I want you to convert that back to a mixed number. I'm going to go through this video kind of quickly to see if we can...
Our first mixed number is 2 3/8. I'm going to show 2 holes completely filled in. The fractional part of the mixed number is 3 out of 8, so we're going to represent 3/8 by shading in 3 parts out of 8. Our second mixed number is 2 4/8. So we're going to create another area model, and we see that our denominator is 8, so we're going to be able to add these 2 area models together. So we have our 2 holes, and then 4 out of 8 parts are shaded in.
Okay, I'm going to pause it right there. This video actually shows you lots of visuals to add. After talking to Miss Sledge and Miss Henry, you can do this approach, but we highly recommend that you turn them into improper fractions and then add them and then convert back into a mixed number. I'm going to pull up the introduction lesson to Unit 15, and we are going to practice with that together. Like I said, I would advise you to watch this video too. I'd advise you to finish watching it. This gives you a great visual representation. Okay. Okay, so we are looking at Unit 15, Introduction. We are going to do number 1. This is very similar to the video that I just paused. It gives you the visual models. Okay, shade this model to show the sum, and when you see the word sum, you know that you are adding something together to find the answer. Okay, the sum of 3 3/4 plus 3 1/4, record your answer. When you're doing these problems, I always want you to make sure that the denominators are the same, which in this case they are, so it makes it fairly easy. Let's first fill in 3 3/4. Okay, the 3 here means 3 holes. Okay, so this is a hole. I'm going to shade that in. This is a hole. And this is a hole. So 3 holes. And then we need to do the fractional piece here. We have 3/4. So there's 1/4, 2/4, 3/4. Okay, so 3 holes and 3/4. Okay. let's do adding that together to 3 wholes and 1/4. Okay, so there's a whole, that's 1 whole, 2 wholes, 3 wholes, and then we have a 4th. You can shade this 4th in right here, but I'm going to complete this whole by shading in a 4th right there, because it doesn't matter whether you shade this 4th in or this 4th in, it's still a 4th, okay? So it says record your answer. When we add all of those together, you can see that there's 1 whole, 2 wholes, 3 wholes, 4 wholes, 5 wholes, 6 wholes, and this is a whole also, so the answer is 7. All right. Let's look at number 3. We're going to skip around a little bit. Okay, so if you look at number 3, it says Callie drives 3 3/4 miles to the store. And another, I definitely would cube these because these are word problems, okay? So if she's driving that and another, that makes me think that my number is going to be getting bigger, okay? So I'm probably going to be doing multiplying or adding. I'm thinking we're going to add, okay? 4 3/4 miles to the mall. The question says, how far does Callie drive? Okay, well, let's think about this. We're going to do 3 wholes, 3 4/10, plus 4 3/10, okay? All right, so number 1, our denominators are the same, so we're good to go. However, I'm going to show you how to convert it to an improper fraction first. Each one we're going to convert into an improper fraction. If you were in my class, I called this rounding your wagons. Miss Sledge said that she calls it go around the world. Okay, I know we didn't have a lot of practice with this before we got out of school, but this is great practice right here. Okay, so to round your wagons or to convert to an improper fraction, you multiply the whole number times the denominator. So in this case, 3 times 10 would be 30, and then you add the numerator in. So you've got 34 tenths. Okay, we are going to convert 4 3/10 into an improper fraction. This is an improper fraction, so we're going to convert. So we've got 4 times 10, which is 40, plus 3, 43 tenths. Okay. So now that we've got the same denominator, we're going to just add the numerators. Okay. So we've got 34 plus 43. Which gives you 77 tenths. However, you cannot leave your answer as 77 tenths because it's improper. So therefore, we have to convert it back into a mixed number. Okay? So how would you convert an improper fraction to a mixed number? Okay? This is where you would divide. Okay? How many times will 10 go into 77 without going over? I explained in my class that it goes in 7 whole times, and I make that number 7 very big right there, okay? 7 whole times. 7 times 10 is 70. You subtract, and you have 7 left over. However, you cannot divide anything else, so your remainder becomes your numerator, and your divisor is your denominator. So the answer to the problem is 7 7/10. Okay? That was a lot of work. You've got to make sure you pay attention. Okay? All right? Okay, we're going to continue with number 6. We're going to skip around a little bit. Number 6, Matenko worked 7 1/4 hours at a florist on Saturday. On Sunday, he worked 3 2/4 fewer. I'm going to box in fewer because automatically when I see fewer, it makes me think that my number is going to be getting smaller, okay? Fewer hours than he worked on Saturday. How many hours did Atenko work on Sunday? I usually would set mine up by telling me what I know. I've got Saturday and I've got Sunday. Okay, on Saturday, he worked 7 1/4 hours. And on Sunday, he worked 3 2/4 fewer. So we really don't know how many hours he worked Sunday. We just know that it is 3 2/4 hours less than Saturday. Okay, so let's see if we can do a subtraction problem to actually figure out how many hours he worked on Sunday. Okay, so we've got 7 1/4 minus 3 2/4. Okay, all right, so when you're setting this up, I never, ever, ever want you to subtract the whole numbers and then try and subtract the fraction. You will likely mess up if you do that. So what I really want you to do is convert it into improper fractions, subtract, and then take your answer and turn it back into a mixed number, okay? So let's turn this into an improper fraction by rounding your wagons or going around the world. 7 times 4 is 28, plus 1 is 29 fourths. Okay, minus 3 times 4, which is 12, plus 2, 14 fourths. Okay, so now that we have two improper fractions with the same denominator, we can subtract. Okay, let's see. Let's do 29, subtract 14, which you've got 15, and then your denominator always stays the same, 15 fourths, right there. Okay, so technically that is our answer, but we cannot leave it as an improper fraction. We're going to have to convert that back to a mixed number, and how you would do that would be dividing this. Okay, and how many times does 4 go into 15 without going over? Okay, how many times does 4 go into 15 without going over? It goes in 3 whole times, okay? And 3 times 4 is 12. You subtract and you get 3. You cannot divide anything else, therefore your remainder of 3 becomes your numerator, and your divisor becomes your denominator. I hope you guys can see that. It's kind of, not really have a lot of room here. Okay. Therefore, the answer is 3 3/4. Okay, so that's how many hours he worked on Sunday. All right. All right, guys. Again, we're skipping around. This is number 4. Okay. Nika makes a kite. He cuts one length of the string that is 6 2/4 inches long. He cuts another length of a string that is 8 3/4 inches long. The question says, how many inches of a string does Nico cut to make his kite? So we've got to also think about, because this is a word problem, we've got to think about what operation we are using here. It sounds like they're getting us to find the total amount of string he used to make his kite. Therefore, our number is getting bigger, so we are going to add. All right, so let's do 6 2/4 plus 8 3/4. Okay, again, we are going to convert these mixed numbers to improper fractions before we add. I know it's tempting, but you do not want to add the whole numbers and then add the fractions. You are very likely to make a mistake. Okay, so let's do a little extra work to make sure we get the right answer. To convert to mixed number to an improper fraction, we're going to round our wagons. Okay, so we're going to multiply and then add. 6 times 4 is 24. plus 2 is going to give us 26 fourths. Okay, so we figured that one out. Got to round our wagons here. Okay, so 8 times 4 is 32, plus 3 is 35 fourths. Okay, so now we have 26 fourths plus 35 fourths. Okay, your denominator is not going to change. We're going to move that over, and we are going to add the numerators. 26 plus 35 is going to give us 61 fourths. Okay, so that is your answer, but we are going to convert that back into a mixed number. Okay, and by doing that, we divide 61 divided by 4. Okay, and so 4 goes, actually you can do 4 into 6. 1 large time, 4, 2, 1. How many times will 4 go into 21 without going over? It goes in 5 large times. 5 times 4 is 20. Subtract, you have 1 left over. Your remainder of 1 is going to become your numerator, and your denominator is always your divisor. So the answer is 15 1/4 inches of string. Okay? Perfect. Okay, so we are going to do number 2. As you can tell, we left number 2 and number 5. We haven't done those yet, and mainly because they're two-step problems. So I needed to show you the basics before we got here. Okay, so the art teacher ordered 8 boxes of construction paper. The students have used 3 7/8 boxes for art projects and 3 5/8 boxes for assignments. Okay, so the question says how much construction paper has not been used. Okay, well, let's first figure out how much they have used and then subtract it by the amount of boxes that they had. Okay, so by doing that, we are going to figure out how much they actually used. So let's figure out total how much they've used so far. So we know that they've used 3 7/8 boxes art projects and 3 5/8 boxes for assignments. Okay, this is the total used. Okay, which is not going to be our answer. We are not going to put this sum as our answer. Okay, it's not asking us for how much we used. So they're trying to ask us how much has not been used. Okay, so let's do the same process. We're going to convert into an improper fraction by rounding our wagons. We are going to do 3 times 8, which is 24, plus 7 will give us 31/8 plus 3 times 8 is 24, plus 5 is 29/8. Okay, so let's add that together. We have 29/8 plus 31. Okay, so this stays the same. And then we've got a total of 68 is how much they have used. Okay. Okay, so that's how much they have used. Now, I really need you to pay attention to this 8 whole boxes because it's really important. Okay, so let's talk about what 8 whole boxes would mean when your denominator is 8. Let's talk about if it was 1 whole box. What would that fraction look like? It would be 1 whole box would be 8/8. Okay, but it's actually saying, let's talk about 2 boxes. If you had 2 full boxes, it would actually look like that. Okay, well, I wonder what 8 whole boxes would look like. What would be our numerator and what would be our denominator? Well, it's almost doing like 8 times 1 is 8, 8 times 2 is 16. 8 times what? It's going to be right here. How about 64/8? Because if we were to actually divide 64 divided by 8, it would give us 8 wholes. Okay, so this as 8 as a fraction with a denominator of 8 would be 64/8 is the total amount in the box. Okay, so we've got 64/8 in the box, and I know that they have used 68. Okay, so I think we can probably do a subtraction problem to figure out what's left. Okay, so we have 64/8 that was in the box, and then they used 68 of the paper. Okay, and everything's already converted to improper fractions, so we just need to do the subtraction problem. Our denominator does not change, and 64 minus 60 is going to give us 4. Okay, so what is left in the box is 4/8, and hopefully you can look at 4/8 and see that that is equivalent to half of the box. 1/2 of the box is left. All right, go to number 5. Buddy ate 2/12 of a bag of peanuts on Monday, 5/12 of a bag on Tuesday, and 4/12 of the bag on Wednesday. Okay, let's look at the question. What fraction of the bag of peanuts was left on Thursday? Left is really important, okay? So let's first write out what we know. Monday, Tuesday, Wednesday, Thursday. So Monday, we know that he ate 2/12 of the bag. Tuesday, he ate 5/12 of the bag. Wednesday, he ate 4/12 of the bag. And Thursday is actually what we're looking for. But in order to do this problem, you have to know that the bag is divided into 12 parts. Okay, so what would a whole bag look like? A whole bag would look like 12/12. Okay, so we know if we add all these together, we're going to figure out how much he's eaten so far. So let's go ahead and do that. And this is not going to be extremely hard because everything is already a proper fraction. So you do not need to convert anything. So your denominator is going to stay at 12, and we can just add across. 2 plus 5 is 7, and 7 plus 4 is 11. So between Monday, Tuesday, and Wednesday, he ate 11/12. Okay, well, how much is left on Thursday? Because this is the whole bag right here, and he ate this much. So how much of the bag is left? I guess we could do this. But hopefully you can visually see that the only thing left for him to eat on Thursday was 1/12 of the bag. Okay, so the answer is 1/12. Okay, so for the sake of time, we are not going to pull out all the definition cards. I want you to look at the vocabulary words. This is still Unit 15. I just flipped the page over. Okay, this is the journal portion. I think we know the definition of add, addition, denominator. You should know equivalent fraction, a fraction. To join may be a new term for you, but that just means to combine or put together. Okay, like denominators. Denominators that are the same. They just have the same denominator. A mixed number is also a new term for you. Okay, a mixed number is got, number one, it's more than a whole. Okay, let's see, I'm looking at the definition in the back of the book. It says a number made up of a whole number and a fraction. Okay, so it's whole and a fraction. For example, I'll give you one. There is a mixed number. Okay, 4 2/3. There's a whole number and then there's a fraction. Okay, you should know model, numerator, and operation. So this unit is going to be word problems, so you're going to have to know which operation. Okay, separating, subtract, and subtraction. Okay, so mixed numbers, like denominators, and join were your main three that you really needed to focus on this unit. Let's look at the vocabulary activity, which I've already given you the answer to one. It says circle the mixed numbers. Okay, so you're looking for a mixed number. It's got a whole and then it's got a fraction with it. And then it says write a definition for a mixed number in your own words. Okay, I'm not going to cover that with you. It says draw a model for one of the mixed numbers you circled. Write the number. Okay, So if you would like to look back to number 1 in introduction, that would be a model. So 3 3/4. This would be the model that goes with 3 3/4. 3 wholes and then a fractional piece with your denominator 4. Okay. So you're going to write one of the mixed numbers here and you're going to draw a model to represent it. Okay. And finally, it says journal. Choose a profession. A profession is like a job or a career in which a person might need to add or subtract mixed numbers. Give examples to explain your answer. I want you to think about where you see mixed numbers in life. You may see them in your kitchen. You may see them when you go to the doctor's office. You may see them when you go to Lowe's Home Improvement. You may see them when you go to the grocery store. So I want you to think about all the different jobs that you think you would need to know what mixed numbers are. Okay, and then it says give examples to explain your answer. Okay. When you finish this, you may start partner practice and upload your partner practice answers to the Google form, and just make sure you actually do the work on this paper first.